All right, good morning. Welcome to the Celestial Wheel. I'm QMC Simpson, and today we're going to go over sunrise on a given day. So right now, I have the latitude and longitude. Let me get out of your way. It'll be 36 degrees, 56 minutes, 06 seconds north. And longitude will be 076, 19 minutes, 19 seconds west. This is the strip form from SurfNav. They're readily available, especially if your chief or your navigator has been to SurfNav, and they have them available. Just going 1 all the way to 16 on here, and we're just going to follow every direction. And the good thing about these strip forms is it tells you exactly what to do and where to find it. Okay? All right. Already have latitude and longitude. I always circle sunrise right here so I know what part of the Nautical Almanac I'm going to be looking at. And we're going to put today's date. Today's date is the 28th of October, 2025. With that being said, make sure you're using the 2025 Nautical Almanac. Number 3, we're just going to take down our DR latitude. Straight from number 1, so 36 degrees, 56 minutes, 06 seconds north. Always label with the symbols and northwest, southeast, whatever you're using. Now we have to go into the Nautical Almanac itself. We're going to find the differences in the tabulated interval where 36 degrees is. So if you look at the Nautical Almanac on this specific day, 36 lies in between 40 degrees and 35. Okay. As we're at it, we're going to go ahead and get the sunrise times for those 2 degrees. 40 is 0626, 35 is 0618. So now we're going to look at the difference between the tabulated intervals. 35 to 40, that is a 5-degree difference. So write 5 degrees right there. Number 5, the lat difference, the difference in time between your tabulated latitudes. Differences in time. So we're going to be looking at these 2 times right here. The difference is 8 minutes. Moving on to number 6, the lat difference, the difference between your DR latitude and your base latitude, the latitude closest to the equator. So we got 36 degrees, 56, 06. 35 is closer to that. You're going to find differences between those two. Relatively easy. It's a 1 degree, 56, 06 difference. I like to go ahead and convert that. It'll make the math a hell of a lot easier. So basically, using the whole calculator method, you'll take 06 divided by 60.1 plus 56, you get 56.1. Divide that by 60, you get 0.935. Making this 1 degree, 935 degrees. Now we did that to make the math easier. You see in number 7, we have the correction. Lat difference divided by tabulated interval times the lat difference. So taking number 6, 1.935, divided by the lat difference, or excuse me, the tabulated difference, you get 0.387 times that by 8. And you get about 3 minutes. It's 3.09. I'm just rounding to 3 minutes. Now, since we used 35 right here, number 8 is asking for the time extracted from the Nautical Almanac referring to the base latitude. We use this base as 35, so we're going to use 0618. Now, a little trick to remember to this next part. 36 is in between 40 and 35. And the number on the time is increasing. So we're going to want to be in between these two times. We're going to add it. You're simply adding it to the tabulated LMT, making it 0621. So far, we're about halfway done. We did it for the latitude. Now we have to do it for the longitude. We're going to take our longitude from the top, 076 degrees, 19 minutes, 19 seconds west. Now we have to determine our standard meridian. For this, I kind of like to draw a miniature time chart or world chart. Just make little lines. I always do like 3 of them. And we increase this way going west. So everything's by 15s. So this standard time zone, plus 15, 075, plus 15, 090. Looking at our longitude, we lie somewhere right here. Making our standard meridian 075. Okay? Also note what side of that line we are on. We're using 7.5, we're at 7.6, so we have to add to get to that point. Now once we find this difference, we're going to end up adding that later. Number 12, the difference between standard meridian and DR longitude and degrees, minutes, and seconds. Another fairly easy one. So you're taking 076 degrees, 19 minutes, 19 seconds west, minus 075. That is 1 degree, 19 seconds. Next one is to convert that, arc to time. So basically what I like to do is turn this into one number. So 19 divided by 60 plus 19, you get a 19.3 blah, blah, blah. Divide that by 60 plus 1, making that about 1.3, looks like a 5. Two. Degrees. Now they want you to convert degrees to time. And it gives you this right here, 1 degree of arc equals 4 minutes. We can just take that, or you can just keep in your calculator, 1.32 times 4 equals 5.28 minutes. Now you remember what I said about over here, since we're using the standard meridian right here, we're adding to get to 076. So we're going to put a plus right here, telling us we will add that. Number 14, taking our time that we got previously, 0621, and then the next one, we're taking number 14 plus or minus number 13. We end up adding it, so we're going to plus 5 minutes, 0.28. That gives us 0626, roughly. But it's a catch. We're still in October, so in between March and October, November 1st is when we go back to +5 Romeo. So right now we're in still +4 Quebec. So we have to add an hour for daylight savings, making it 0726 zone time. Now this is just specifically for that latitude and longitude and that date. Sunset has its own little tabulated table. You do the same thing, same math, but with just sunset. And that'll be the next video.